And then the most complicated questions would look something like this. Use algebra to solve. So I notice that there's a cos and a cos squared, which makes it a quadratic equation. We have two techniques for solving quadratic equations from grade 11. Well, we have three, but one we never use again. The two that you use is factoring and the quadratic formula. In order to use either of those, you need to make one side equal to 0. So I always like to make my square thing positive. So you notice right now, in front of the cos squared is a -3. So I'm going to move everything to the left side. I'm going to move that to the left side. I still have the cos x on the left side, but when I move the 1 over to the left side, it'll be -1. And I make one side equal to 0. Next, you should ask yourself, can I factor? Because if you can factor, that's the fastest. If the answer to that question is yes, then factor. If the answer to that question is no, then use the quadratic formula. If the answer to that question is I don't know, then use the quadratic formula. Because the quadratic formula will work whether you can factor it or whether you can't factor it. Factoring doesn't work when you can't factor it. Does that kind of make sense? Okay. So if you're unsure, use the quadratic formula. You cannot factor this. So we're going to have to use our quadratic formula. It's a cos squared, so we'd write cos x equals, here's the right. Might be asking, how close are you to memorizing that formula? Okay, negative b, so my b value is a positive 1, so I'd write -1 plus or minus 1 squared will be 1 minus 4, a is 3, c is a -1 over 2a, just 2 times 3. Again, I always, with the quadratic formula, split it up into the two separate ones. So with the positive, simplify inside there, that's going to be 1 plus 12 is 13 over 6. And with the negative, -1 minus the square root of 13 all over 6. Change these to decimals because, okay, you might get some shortcuts. We might not, but we might get some shortcuts. Ideally, you know what would be wonderful in this question? Is if inside the square root it ended up being a -13. It's so nice because you can just say not possible at that moment and not have to do any more work. Because you can't square root a negative. Unfortunately, it's a 13. So I'm going to go to my calculator and I'm going to see what these numbers actually are. -1 plus the square root of 13. Over 6 and -1 minus the square root of 13 over 6. 0.434 and -0.768. Four, 3, 4, 7, 6, 8. Then here's where another shortcut could be a possibility. If either of them were numbers bigger than 1, because it's cos, you could just say not possible on that side. Of course, the textbook wanted us to inflict as much pain as possible, so they made them both possible. What do we have to do? Obviously, they're not on our pie plate. We have to do the same process of finding a reference angle and using our Castro. So, reference angle for this one, cos inverse of 0.434. I'll do this side first. second cos inverse of this one. Push enter. 64.261. Or are we in degrees or radians?
Radians.
We're in radians. So I have to go back to my calculator, hit the mode button, change it to radians, and type it in again. And I get a reference angle of 1.122. So my actual answer is between 0 and 2 pi. What do they want? They want, they say, oh, they don't say. They don't say how many decimal places? Oh yeah, they do, to the nearest 100. That's what I was wondering. So, this is positive, so I'll be in quadrant 1 to the nearest 100. And quadrant 2, I'll take out my calculator. Quadrant 2 would be pi minus my reference angle, 2.02. On the other side, I'm going to find my reference angle. Again, I'll go cos inverse. I'm going to do cos inverse of this one. Of course, that has a negative, so I need to multiply by a -1 to make it positive. Find my reference angle. 0.696. But because cos is negative, I'll look in quadrants 2 and quadrants 3. So I'm going to use that store button again. Store that reference angle as x. Quadrant 2 will be minus x. And quadrant 3 would be pi plus x. To the nearest hundredth, 2.45, 3.84. And both of these are solutions between 0 and 2 pi. Is that what we wanted? No. They wanted the solutions. What is it, negative pi to pi? Is that what they wanted? Yes. Oh. So, if I label above these solutions, do you see this one was in quadrant 1, this one was in quadrant... I made a mistake with that one, didn't I? Because it's supposed to be in quadrant 4. Did I take the one in quadrant 4? You guys didn't let me, you just let me make that mistake? I've got to go change that one. Thanks a lot. This one was in quadrant 3, and this one was in, no, that one's quadrant 2. That one's in quadrant 2. This one was in quadrant 3. Those ones were okay. I gotta go back. This one is a mistake. In quadrant 4, I'd have to do 2 pi minus that reference angle. Two pi minus, gotta go find that reference angle. There it is. I should have got 5.16. Not that it matters, because now they want me to find it from negative pi to pi. So that's going to be positive answers from 0 to pi. So my solutions in blue, can you see the one in quadrant 1 is fine? And the one in quadrant 2 is fine. But this one, I have to rewrite. And this one, I'm going to have to rewrite. What's coterminal with 5.16? If I subtract 2 pi, I'm going to find out it's negative 1.12. And if I subtract 2 pi on this one, negative 2.45. we'll end there. I know it says in part B to write the general solution, but the general solution, I would take all 4 of those in black and just add 2 K-pop. So that wouldn't be too bad to do. And you can circle questions 12, 13, and 14.
How many marks? Like